Okay, Calc, it's Friday. Hopefully this is the last day we'll have to do this, and then I'll see you in person on Monday. But section 2.3 is what we're going to be doing today. So this is polynomial division and synthetic division. Polynomial division is another form or another way to say long division. So I don't know if you guys remember this from trig or from algebra 2 at all. Long division can get kind of messy. Synthetic division a lot of people like better. So they start us off with long division. The way that they have this box set up, and I want you to kind of look at this piece here. They have some terminology in here like the dividend and the divisor. So I'm taking the dividend and I'm dividing by the divisor, and that gives me the quotient plus the remainder, and we always put the remainder over the divisor. So like, let's say if I was taking 13 and I was dividing by 2, this would be my dividend, this would be my divisor, okay, equals 13 divided by 2 is 6 plus 1/2. Usually we just write it as 6 1/2 and we don't put the plus sign in there, but 6 1/2, this guy is the quotient, and then the remainder is 1, and the divisor is 2. So that's kind of how that breaks down, okay? They have the same thing over here, but this is for a polynomial. So if I'm taking x squared plus 3x plus 5 as my dividend, dividing by x plus 1, that gives me a quotient of x plus 2, and then the remainder is 3, and I put that over x plus 1, which is what I was dividing by. Okay, they're going to have us do an example 1 and 2 down below here. But before they do that, let's talk about proper versus improper. There are improper fractions. Usually you think of them as like 3/2 is an improper fraction. If you convert that to a mixed number, it's 1 1/2. Okay, so a proper fraction would be, something that's in reduced form, where your top number is lower than your bottom number, but this is considered to be improper. In the same way that this one is improper because the highest power of x in the numerator is squared, and the highest power in the denominator is to the first power. So the top is heavier than the bottom. In this one, my bottom power is 1, and then my top power is kind of like saying x to the 0 power. So the top is smaller than the bottom. So he is proper. The top one is improper. Okay, so they're going to have us in example 1 divide this out. So I'm taking x cubed minus 1, and I'm dividing by x minus 1. So I'm going to put x minus 1 on the outside, and then I'm dividing. So I set this up here, and the only thing that I will warn you about is if you have terms that are missing, like in between the x cubed and the 1, put zeros in front of them. So I need to put out plus 0x squared plus 0x, and then I can finally put my minus 1. So you do need to leave place values or placeholders for those x squared and that x value, okay? And then here we get into it. The first thing that you ask yourself is, what do I have to multiply by x to get x to the third power? And that is x squared. So I'm going to put that at the top. And then after I determine that, I multiply it back through for both of those pieces. So x squared times x is x to the third power. And then x squared times -1 is negative x squared. Okay? And then what I do is, after I have distributed that back through, I switch the symbol. So I change this to a minus sign, and I change this to a plus sign. Okay, when I do that, the x cubed minus the x cubed cancels out, but then I have 0x squared plus x squared, and this is like 1x squared, okay? And what that's going to give me is a 1x squared, and then I drop this guy down, plus 0x, okay? Now I repeat the process all over again. I'm going to start by saying, what do I have to multiply? What do I have to multiply by x to get x squared? And that is a positive x, okay? X times x squared, if I distribute back through, or excuse me, x times x is x squared. And then I take x times -1, which is negative x, okay? Then I still have to flip the sign, so minus, what is happening? Go away. Go away. All right. There we go. There we go. Okay. All right, so now I have to flip my sign. So I switch this to a minus, this guy to a plus. That cancels that first part out, just like it did in the above step. And then I take 0x plus x, which is just an x, and then I drop my minus 1 down, minus 1. Okay. Last step, I do the same thing again. What do I take times x to get x? X times a positive 1 will give me x. So then I distribute it back through. 1 times x is x. 1 times negative 1 is negative 1. Okay. Last, I have to flip the sign again. So this changes to a minus. This changes to a plus. That cancels out just like it did here and here. And negative 1 plus 1 is 0. So I have a remainder of 0. And this is all I have for my solution. Okay. X squared plus x plus 1. That is what I get when I divide those two things out. Okay. All right. Example 2, they're going to have me divide that again as well. Let's get this thing set up, and we need to make sure that if there are things that we need to have a placeholder for, we put that in. We're dividing by x squared plus 2x minus 3, so that's going to go out here on the side. X squared plus 2x minus 3. And the stuff that goes underneath on the inside is the 2x to the 4th plus 4x to the 3rd minus 5x squared plus 3x minus 2. Now, in all of that stuff, I did not have to put any placeholders. I have an x to the 4th, an x to the 3rd, an x to the 2nd, an x, and then a number. I have all of those things, okay? Here I had an x squared, an x, and a number. So even with this part that's out here on the side, if he does not have, you know, a certain value in there, you will need to put a placeholder like plus 0x or plus 0x squared or whatever he's missing in the inside, okay? So keep that in mind for both the inside here and the outside part. You need to do that for, okay? All right. First thing we look at is this x squared and the 2x to the 4th. What do we have to multiply? We would need to multiply by a 2x squared to get him to be 2x to the 4th. So I take that 2x squared and I multiply him here, here, and here. Okay, so 2x squared times x squared is 2x to the 4th. 2x squared times 2x is 4x cubed, and it's positive. And then 2x squared times negative 3 is negative 6x squared. Okay, then I'm going to switch the signs. So this becomes negative, this becomes negative, this becomes positive. Okay, so this guy cancels out. And 4x cubed minus 4x cubed, that's going to cancel out also. Okay, so just bear with me for just a second, all right? Negative 5x squared plus 6x squared is 1x squared. And because I had two things that canceled out, what I'm going to do is I'm going to drop the 3x down, but I'm also going to drop the negative 2 down, okay? Because normally we just drop one of them down, but because I had both things cancel out, I'm going to drop a second piece down as well, okay? And then we start the process over again. And now because I had nothing, or because this guy canceled out here, I'm not going to have anything in this spot, okay? So I'm going to kind of move him over, and the next thing that I'm going to write is going to be above the 3rd position because I had that thing that canceled, okay? So I'm looking at this guy right here, 1x squared, and I say, what do I have to take times x squared to get 1x squared? I have to take him times a positive 1. 1 times x squared will give me 1x squared. 1 times negative 2, or excuse me, 1 times positive 2x gives me plus 2x, and then 1 times negative 3 is a negative 3, okay? I'm just taking this guy and multiplying him through for all three of those pieces, okay? And then I flip the signs. So this becomes negative, negative, positive, okay? And I have 1x squared minus 1x squared. That's what I wanted to have happen. I have 3x minus 2x, which gives me just an x, and I have negative 2 plus 3, which is a positive 1, okay? Now, at this point, I am done because if I would try to repeat this process again, there's nothing that I can multiply by x squared to get x, right? I could really multiply by 1 over x or whatever, you know, to get x, but no whole solution answer, you know, this part right here is already lower than what I'm dividing by. So this entire piece right here is going to be my remainder. So I write that as plus x plus 1 over x squared plus 2x minus 3. So I put this guy over top of this guy, and that's what my remainder will look like. So let me write that off to the side over here so it looks a little bit nicer. I had 2x squared plus 1. I didn't have any value of x, so I had like plus 0x in here basically. And then my remainder was plus x plus 1 over x squared plus 2x minus 3. This is my long division solution. Okay? All right, so let's go down here and we'll do a synthetic division problem. I think I'm going to cut this video a little bit short though. We'll do this synthetic division problem and then we will stop. Okay, so I don't want to make this video too terribly long. Use synthetic division to divide. All right, a lot of people really like synthetic division. In fact, people prefer that over long division, but the reason why we don't use synthetic division all the time is because you cannot use it all the time. This problem that we just got done doing, you can only do long division with that problem, okay? And we'll talk about that here in just a second. So synthetic division, we have x to the fourth minus 10x squared minus 2x plus 4, and we are dividing by x plus 3. Okay, the first thing that you want to do for synthetic division is you want to take x plus 3 and you want to set it equal to 0. And if I set that equal to 0 and I solve for x is equal to negative 3. Okay, now negative 3 is what's going to go on the outside of my synthetic division. Okay, and synthetic division is set up a little bit different. Okay, so negative 3 goes on the outside here, and I kind of do my box the other direction, kind of like this one is set up over here. This would be my negative 3. Whoop. Negative 3 goes in this spot, and then I, make my box go the other direction. Okay, the numbers that go up here at the top, okay, are going to be the coefficients that are in front of my x's here. So x to the fourth is my first number, or my first term, and the number that's in front of that is 1. So I have a 1 here. And then you have to be kind of careful because we don't have an x to the third power. X to the third power, there is not one of those. So we have to put 0 in its spot, okay? Then I have an x to the second power, which is negative 10. Then I have an x, which is negative 2, and then I have a number by itself, which is, I don't necessarily need the positive, which is 4, okay? So you want to space those out even enough so that it doesn't kind of look like they're all running together, just kind of leave spaces in between those numbers, okay? And then here's the steps for synthetic division. The first number we drop down, it is a 1, okay? And then what I'm going to do is I take the negative 3 and I multiply by the 1 to get this number here. 1 or negative 3 times 1 is negative 3. And then I add these two. 0 plus a negative 3 is negative 3. And then I multiply again. Multiply. Negative 3 times negative 3 is a positive 9. Then I add these guys. Negative 10 and positive 9 makes negative 1. And then I multiply. So I'm multiplying and then adding and multiplying and adding and multiplying and adding and multiplying and adding each time. Okay. So negative 3 times negative 1 is a positive 3. And then I add these two. Negative 2 plus 3 is 1. Negative 3 times 1 is a negative 3. And 4 minus 3 is 1. And that last number, I'm going to have you put it in a box because that's going to be my remainder. All right. Now, if you remember up here from long division, every time we would write a step down here, we would have to change the symbol of everything. Okay. We don't have to do that down here because this number that goes out on this side here, we already changed the symbol of him from a positive 3 in the x plus 3 to a negative 3. So doing that changes the sign all the way through, kind of like we had to do that for each one of these steps here. We had to change the symbol or make everything negative. So by doing that in the first step, we've already kind of applied that negative all the way through. Okay, so these numbers here, I want to put them back into my or back into an equation. All right, so I was taking something like x to the fourth and I was dividing by x. X to the fourth divided by x means that this term right here is going to start out as an x to the third power, okay? And this coefficient in front of it is 1. So we would start with 1 x to the third power. Then this negative 3 here would be minus 3x squared minus 1x plus 1, because that's a positive 1. And then plus my remainder is 1 over what I was dividing by was x plus 3. Okay, so you kind of just build your equation back with all these coefficients that you had, and your polynomial is going to be one less power than what you started with. So this guy was an x to the third power. He was originally an x to the fourth power. Okay, so that's kind of how we just build him back. All right, now the thing about synthetic division versus long division, we are only able to use synthetic division to divide things like x plus 3 or x minus something, right? It's got to be just x to the first power, okay? And that's all that we're able to do with synthetic division, okay? So up here in this problem, I'm going to get rid of all my stuff that was going on here. Okay, for this problem, we were taking this polynomial and we were dividing by x squared, which we can't do. Now, we could get around that by taking and breaking down x plus 2x, or excuse me, x squared plus 2x minus 3. That thing will break down into x plus 3 and x minus 1, right? So what I could do instead is I can do a double synthetic division, the first time dividing by x plus 3 and the second time dividing by x minus 1. I'm going to show you what that looks like. So if I have x plus 3, that means x equals negative 3. If I set that equal to 0, and I have x equals positive 1. So what I'm going to do is I'm going to do back-to-back synthetic division, and I'll show you kind of how this looks. Let's start with a negative 3 off to the side over here. Okay, my coefficients are 2, 4, negative 5, 3, and negative 2. 2, 4, negative 5, 3, and negative 2. Okay, and we'll see what this thing looks like. All right. Okay, we'll see. All right. So, I'm going to drop, what was I dividing by 1? Yep, 1. Okay, so we're going to drop the 2 down to start with. Okay, negative 3 times 2 is negative 6. Then I'd add the 4 and the negative 6 together to make negative 2. 3 times negative 2 is positive 6. Negative 5 and 6 together make 1. Then I have negative 3 times 1 is negative 3, and that together gives me 0. And negative 3 times 0 is 0, and that drop down is a negative 2. Okay? Then I'm going to do the same thing with the 1. So I'm going to drop the 2 down. 1 times 2 is 2. That gives me 0 here. 1 times 0 is 0. 1 plus 0 is 1. 1 times 1 is 1. 0 plus 1 is 1. And 1 times 1 is 1. And negative 2 and 1 is negative 1. Okay, now, here's the deal. Because I did this twice, both of these numbers are going to be my remainder. Okay, so what this looks like is I was taking an x to the fourth power, and I was dividing by an x twice. So this guy right here should be x to the second power, because I started with x to the fourth power, I divided by an x, and then I divided by an x again. So that's reducing this guy 2 powers, which makes him an x to the second power. This is going to be an x to the first power. This is going to be just a number, and then this is my remainder. Okay, so I have 2x squared plus 0x, which we really don't need to put in there, plus 1, and then this guy is my remainder, which is going to look like plus 1x minus 1 over what I was dividing by, which was x plus 3 and x minus 1, or x squared plus 2x minus 3. That's exactly what we got. Oh, wait a second. I have a symbol wrong. 2x squared plus 1. Where did I get my symbol wrong? I don't know. Okay, so a lot of people really like synthetic division because it comes out, you strip away all the x's and you just have to deal with the numbers then, and it makes it really a lot nicer looking, and then you just have to put it back together at the end. But the reason why you cannot use synthetic division all the time is you can only use synthetic division when you are dividing by an x to the first power, okay? So, things like x plus 3 or x minus 7 or whatever like that. Example 2 that we did up here that we got an answer for, we were dividing by x squared plus 2x minus 3, and that's a quadratic function. So we have to use long division in that case unless we want to, the only other thing that we can get around that is x squared plus 2x minus 3 will break down into x plus 3 and x minus 1. That's how this quadratic breaks down. He's a simple trinomial, x plus 3, x minus 1. So what we could do is we could do back-to-back synthetic division, which I'm not going to do, but I'm going to just kind of show you how you would set this up. X would be equal to negative 3 and x would be equal to 1. So I have negative 3 and 1, and I would set up all my coefficients here, and then I would just do my synthetic division twice. So it's doing synthetic division twice versus just doing long division once when you're dividing this, but my final answer would be, this whatever answer that I get down here after I synthetic divide twice, okay? So that's the only way that you can kind of get around that, but usually just go with the long division if it's any other power that's higher than x to the first power that you are dividing, okay? So I'm going to stop there. We'll do the remainder theorem and the factor theorem and those type of things, as well as review some of this stuff on Monday.